Polynomial functions. He said he might be a little bit late. I put a little crying emoji, which apparently when you do the little crying emoji, it makes a little rain cloud go over the text, which I thought was quite funny. Polynomial functions. So, polynomials are functions that are, polynomial functions are in this form. What's up, bro? We were gossiping about you. Oh, why did I put in there? Sorry, my bad. F of x. How about? That makes a lot more sense in context, yes?
Is that tiny in, is that a subtext on the first A?
Yes.
So it's
Subscript, but yes.
this looks terrible.
1, right? Is that what we're doing? Yes, it is. Technically, that x to the 0, of course, is not necessary. In fact, the book omits it, but it continues the pattern.
It's a 1.
That is a 1. Okay. Let me get there. It's not very complicated. Okay. So this is just generic form, right? So you can have, so a to the n, a sub n has a name in context. This is all, everything that we've written on the board is things that you've seen before, right? This is just kind of formally writing things out. The a sub n has a name. His name is the leading coefficient, right? Which maybe has 2 f's. Does it have 2 f's? Let's find out. It does. That's the leading coefficient, which is the number in front of the highest x term, the one with the biggest exponent, right? So this one will be the one less exponent, all the way down to just one exponent of 1 and then no x, or exponent 0, same thing, right? Okay. The n also has a name. That is the degree of the polynomial, right? We've seen this before. For sure, for sure. Right? If we have something like f of x equals 2x to the 4th minus 3x plus 1, this is a 4th degree polynomial. It's missing some terms, but it's still a 4th degree polynomial with a leading coefficient of 2, yeah? Making sense? All the things doth we remember? Yes? Yes.
The degree of 4 is in the A.
Because the highest exponent is a 4.
Highest exponent makes it.
Is the degree. Yes.
And then the x to the 0 just means that there's no coefficient?
There's no x. So this is actually a constant term. So like the book doesn't even write the x to the 0 on there because x to the 0 would just be 1, right? Yes. And so there's not an x. Just continuing the pattern all the way down to 0, we would put x to the 0, but it just means 1. That term. Oh, I almost forgot to put a note. This term has a name as well. This is the constant term. It's worth noting for future reference, and I think, is this going to be on this little chart we're about to do? No, it's not. But for future reference, and worth noting, this is something y'all probably would be able to glean on your own, almost certainly, is that a naught, that a sub 0, that's always going to be the y-intercept, right? Because when we clear all of this, that's all that's left. So this one's always going to be the y-intercept, always, right?
The A to the 0 or just...
Not to the 0, but a naught, yes, a sub 0. Yeah. If if a was to the 0, then the y-intercept would be 1. Okay. Let's talk about end behavior, everybody's favorite subject. What I told them, Aiden, is that when the notes thing pops up on the deal, this will be the notes that you will submit, which means it won't be due yesterday. Hopefully not. As long if it is due yesterday, somebody should write me a snarky comment saying that's impossible or something, because that would just be a kind of silly mistake. Or maybe now I'll do it on purpose just to see what kind of snarky comments I can get back. Who knows? Like, as long as you don't count off for it, it's fine. Which would also be funny. Maybe I should do all of that and then see about those kind of snarky comments. That way we could get all kinds of fun things happening.
Your home address so I can just like
I got you.
Do we want to do that? Not really. We're going to go straight to this. Okay. End behavior. All right. So, if n is odd, and a sub n is positive, then the limit of f of x as x approaches negative infinity is negative infinity. So as we're building a little picture of this, do it in slightly different order than what I would do if it was a pre-recorded video. As we're building a picture, what we've got so far is that as we go to the left, our graph is going to be going down, right? That's what we got so far. The limit of f of x as x approaches positive infinity of this one is positive infinity, or just infinity, right? So that means the end behavior here is going to go this way. Now something's going to happen in the middle, who knows what, something like that-ish, right? Something's going to go on in the middle, right?
My brain said, why did you put a graph inside of a graph for a second?
Because magic.
What does the sub n mean?
The leading coefficient.
Oh, yeah.
It's on the page, probably.
Okay, 1 second, I need to fix my notes.
Okay. I'm going to...
Sub in when there's not usually a subscript.
What?
In the things there's not a subscript on the A.
Well, A is a number.
Yes.
In like
but
the
there's
real
no
deal.
subscript of A, so why is it called?
What do you mean there's no subscript of A? I don't understand what you're asking.
When you're writing it, you don't have the number and then a subscript and then X.
So the subscript is representing the nth term, the nth coefficient on there. And so like the next one is n minus 1, so it would be the one less than that. Or what, and then one less than that all the way down to the first one. And then the 0th one, which most of the time we say the a sub 0 or x sub 0, we say it a naught. That's what I mean when I say that.
So there's not actually going to be a subscript. It's just saying that thing to come after.
Yeah, it's just a subscripts on variables are just a more descriptive variable.
So it's just saying it's one bigger than the one.
Like if I was making a formula for the green frogs and the brown frogs, I might do f sub g and f sub b, right? That subscripts just are a more descriptive variable. Okay, if n is odd and a sub n is negative, then it has this kind of end behavior. The limit of f of x as x approaches negative infinity is positive infinity. So as we're building our little graph, that says it's going to be up this way, right? As we go to the left, it's heading up, right? And the limit of f of x as x approaches positive infinity is negative infinity. So it's going to be going this way, right? As we go to the right, it's going to be going down. In the middle, something's going to happen we wouldn't know unless we had the actual function, right? Something like that-ish. Isn't it cute? If n is even and a sub n is positive, what is this gonna be? The limit of f of x as x approaches negative infinity, what's it gonna be?
It's gonna be.
Go up? You're right. Positive
Well, I
infinity.
was just holding up like a thing.
Oh, okay. Well, there you go. You're accidentally right. So as we're building this little graph, that means that as we go to the left,
So then
it's going up.
Would it be also positive?
It is. That's accurate. X approaches positive infinity is positive. It's also going to be going up. And in the middle, something's happening. We don't know. Pause the video. Oh no, YouTube had a mind of its own. If n is even, and a sub n is negative, what is this? What are these going to be?
Negative, negative.
Yeah, negative, negative. They're both going down.
So if n is odd, they go in opposite directions. If it's even, they go in the same direction.
Accurate.
And determines which, if it's positive or negative.
Right. Right.
So if n is odd, the two go in opposite directions. If n is even, they go in the same direction. And then ace thing determines which way it goes. So if it goes up or down.
Mhm.
And for the odd ones, if whatever the a of n is determines where the one going towards infinity goes.
You can kind of think about it as like this kind of has a positive slope, kind of, and this has a negative slope, kind of. Like if you drew a lot, like if we drew a linear function over there, then yes. Positive infinity is a negative infinity. And then something happens, and it looks something like that. Isn't it cute?
So cute.
So, turn in your textbook to page 99. double check to make sure the audio was functioning. I should do that. You're all here, but since this is the only notes video you're going to get, you might even need it. Otherwise, who knows?
Whoa.
Nobody's ever commented and say, hey, I'm George from Wisconsin and I'm also watching your videos. But, you know, who knows? Maybe they're just silent. We have to support our public.
Back in 5th grade, my teacher did like online notes, and I remember on one specific video, there's a person who commented asking her what her WhatsApp was, and she was so confused, and she was like, huh? And the person never responded, so I guess I figured out what that was. It took me years to know what
That's
that
silly.
was.
There, I've got on my regular videos, I don't remember whether it was on Algebra 2 or Precal. I think on one of the Precal videos, these people from India, at least it sounds like they're from India, were commenting some silly things like, hi, whatever. And one person was like, if you keep making amazing videos like this, I'm going to have to do terrible things to you. And then somebody else commented like, what do you mean? He's like, exactly what it sounds like. And then that was as far as the conversation went.
Lost in translation here.
Yeah, I don't know. I don't quite understand. I didn't care to like be a part of that conversation, so I just let them have it. So, you know, there it was. Okay, let's look at guided practice 2A. What is the end behavior going to be of guided practice 2A? So right there kind of in the middle of the page at 4x to the 5th minus 8x, et cetera, et cetera, et cetera. What is it going to look like? Is it going to look like this, 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 or this? So is n odd or even? Oh, we'll wait for Garrett to get there. Page 99, Garrett.
Sorry. I'm a slow writer.
You're fine.
That's why I watch a video like 4 times.
Well, you'll still be able to do that.
Cool. 99.
99, 2A. Is n odd or even? Odd, so it's going to be either this one or this one. And then a sub n, is it positive or negative? Positive. So what's it going to look like? Like this, yeah? It's going to be this way
Cult signs and
and this way. And something's going to happen in the middle, right?
just want to write that down.
You can if you want to. I would put GP2A page 99, right? It probably isn't going to look exactly like this, but the end behavior is going to be like that, right? One second. Yep, it is. It's true.
N is odd, and then A is positive, correct?
Mm-hmm.
So it goes like that.
Mm-hmm. It does. All right, what about guided practice 2B?
It's gonna be even, so it's
The leading
gonna be the
coefficient
same,
is positive.
negative, so it's gonna go this way.
So it's going to go down. Yeah, that's right. Beautiful.
Wait, which one?
The
Guided practice 2B.
that one.
No, which one did you say it was going to be?
It's gonna
That
be
one.
like an upside down parabola.
That's okay. Cool.
Yeah,
Thanks, thanks.
with possibly junk in the middle.
Are we gonna figure? Are we gonna have to eventually find what happens in the middle
Yes.
in this lesson?
You actually already know sort of how to do that. You just forgot
Stick it in the
because you learned it last year.
stick it in
No, you're going to confirm it on the graphing calculator, but you're going to have to do algebra and show that you've done algebra. I would absolutely stick it in the graphing calculator to make sure your algebra is correct. In fact, you can even use your graphing calculator to figure out what you're going to shove into your stupid synthetic division problems, because it'll figure things out for you. Okay, so Okay, zeros and turning points.
Will we need a lot of page for this?
Will you what?
Will we need a lot of page for this on the page?
Depends on how big you write. There's not pictures.
Is it just that tiny thing at the end?
What?
Is it a, where is it on? Oh, I found it.
Okay. So zeros, we already know. What are zeros? What are they? They're x-intercepts. That's where it crosses the x-axis. The zeros specifically are like the picture, right? You remember from geometry, there's sometimes we have different words for pictures versus numbers. Zeros are technically the pictures, and the x-intercepts are the pictures, and the zeros are the maths. So these are the same as the x-intercepts, right? Where it crosses that. Turning points would be what? We've used another word for turning points before.
The relative minimums and maximums?
Yeah, that's right. So the extrema, the mins and maxes, yeah? Mins and maxes. That's what those are. Okay, so if you have a polynomial with degree greater than or equal to 1, so in other words, it's not a constant function, basically, is what we're talking about there. Or if it's not a reciprocal function or whatever, because it's not negative either. But polynomial function with degree greater than 1 has at most n distinct zeros, real zeros, we should specify, and at most n minus 1 turning points.
Real zeros
Versus complex zeros.
what's a complex zero?
Well, complex is like I stuff, right? So like I squared and negative 1 things. And it can have imaginary turning points, whatever, imaginary things. So that's where it's not going to cross the x-axis. Yeah, so if it has imaginary zeros, which it can have, then that means it didn't cross the x-axis there. But something else happened. Something else exciting. So let's look at page 100. And let's do guided practices 3A and 3B. So for guided practice 3A, how many possible real zeros and turning points are there?
3.
Which one? Zeros or turning points?
3 zeros and then 2 turning points.
Yeah, at most 2 turning points. That's true. We'll go back and do the second part of the problem here in a second, but let's look at 3B. So we could have how many zeros? 4. And at most how many turning points? N minus 1, so 3. Mm-hmm. Okay. Where are you what in the world in? Are you on a different problem?
No, I have no idea what's happening.
Looking at the problem here, yeah. So what's the degree of this polynomial?
3rd degree.
3rd degree. So that tells us how many the maximum number of zeros is 3.
Okay, cool.
And the maximum number of turning points is that number minus 1. So 2.
Oh, okay.
Same idea here. It's 5 for this one and 4 possible turning points. Yeah.
And you can't just go 3 and 2, right? It has to be
Yeah.
this number minus 1.
Mhm.
Okay, I think that's where I was getting confused. Because I was looking at, I saw these ones and I looked at these ones to practice. And
Well, these are the ones that we were talking about. So 3 and then 2 and then 4 and then 3. You were probably looking at different problems, which is where you got confused.
cool.
Great. Welcome back. Okay. So easy money, right? Now we need to determine all of the zeros by factoring those two problems. So let's do that together. Okay. So this is page 100, 3A. And it is f of x equals x cubed minus 6x squared minus 27x. Okay. So to find the zeros, right, what you would always do is you put a 0 here and then solve that, right? So this equals 0 and then all of that is the same. So we need to factor that. So what do we need to do to factor that mess? What?
I was thinking of completing the square for some reason.
Is there a GCF? Because remember, we always want to look for that first.
Nope.
Ah, there is though.
An X?
They all have an X. There's no number, right? But there is an X. We can go ahead and pull an X out. Right? So now what would we do to factor the thing?
Do the smiley face.
I think that's a great idea.
And then we split it into 2 equations.
3. Right?
Yes.
Questions? Comments? Snide remarks?
The brackets?
You could. I mean, so these are all technically points, right? So if you, I mean, usually we don't worry about writing them as points, but these are all points. Great. So the next one,
The 0 is there because we inserted a 0 in there.
because we set all 3 factors equal to 0, because this is a factor as well. Okay, so y'all factor 3b. Ready to go.
Done. Oh, I didn't like
Nice, nice. What'd you do about the x to the 4th?
It's now x squared minus 5 and x squared minus 3.
Yes, it is.
So the answers are square roots of 3 and 5?
They are. That's
Woo,
accurate.
I wasn't stupid.
Sort of. You missed one thing. You're not stupid, but you forgot something. But you forgot something.
Oh, plus or minus.
Yep, that's it. That's it.
Here's the 4th.
You can factor it out into x squared minus 5 and then x squared minus 3.
How do you do that?
Right? Because the first slot, remember, is 2 things that multiply to get the first term. X squared times x squared will give us, oh, I'm missing squared.
Oh, so you just treat it, okay.
Yeah, which works because if we pull this back out, the outside and inside terms are going to have the x squared that we need, right, for the middle
If
one.
it's like a 5, you couldn't do that. But since it's
Right,
a 4 and a 2,
right,
they're
yes.
And then it's minus minus because the last one gets you a plus and the middle is minus.
Yep, all that's true. And then we'd set each one of these equal to 0, so we'd have x squared equals 5 and 3, and then to get rid of the squared, we'd square root both sides. When we square root both sides, we get plus or minus. So our answers are x equals plus or minus the square root of 5 and plus or minus the square root of 3, right? which we expected there could be up to 4 real zeros, and we found 4 real zeros. There can be less. Less would usually because there's something duplicated, right? Or you end up with some imaginary ones or something like that. But that's where we're going. Great, easy plan, easy money, no big dealio. Okay, Yahoo and such. I love it, so cute. All right, what about quadratic form? This is not a quadratic function. It is a quartic function, yeah? But it is, however, written in quadratic form. So what is quadratic form? Let's define it.
AX squared plus, I don't know actually.
Yeah, you're on the right track. We use different letters typically, but quadratic form is any polynomial that is written in the form a u squared plus u plus bu. Is it bu? Yes, bu. Not Brigham Young, just bu. Plus c. And stipulations in there are that a, of course, cannot be 0 because then it's just linear, right? And, excuse me, and u is some expression in x. And they put it in x. I think in terms of x would be a better wording.
What does that mean?
Okay, so that means you can be anything as long as it's the same thing. So a ugly example. Let's make us an ugly example. That is, we could let u be, let's go way ugly and make it be x squared minus 8 over 3. Then we could write this, and we could write this as a function in quadratic form would look something like this. F of x equals, we'll make up a number for a, how about 5? Doesn't matter. A, b, and c are just numbers, right? And then this is x squared minus 8 over 3 squared plus x squared minus 8 over 3 times b, which is, I don't know, 3. Why not? Plus 4. This is not a quadratic. It's going to be another quartic function, ultimately, because this squared is going to get squared. But it is written in quadratic form. So quadratic form is if it can be if it's written like this, whatever u is, as long as it's in terms of x, and it's written in that form, it's now in quadratic form.
Terms of x, what does that mean?
That means the x is the independent variable. Okay. And x, of course, is the dependent variable. Yeah. We use u. We've talked about this kind of. We've brushed on it before a little bit, and we'll brush on it other times. But this u is used very commonly in calculus as a substitutive variable to make something ugly simpler. You deal with the simpler thing and then shove back in the ugly once you've kind of cleaned up the u thing. So it's used as a substitutive variable often. There's nothing magical about u, just like there's nothing magical about x. It's just these are the variables that are typically used, right? As generic things. So what do we do with quadratic form? That's a dumb example. It's too easy. Is there something better? That's,
See that one?
Well, that's less helpful. All of them are kind of easy. Let's do another one or two, just because, why not? Here we go. Let's do, these are like all the same thing. 4 is too easy. Let's do 5. Let's guided practice 5A together. Okay, so guided practice, I said A, but I think I want to do B. Let's do guided practice 5B. GP 5B on page 101. So we're given f of x equals 3x to the 5th minus 18x to the 4th plus 27x cubed. So this is where in the I would continue. So the book doesn't do this because this is actually in quadratic form already, and we can deal with it like it's in quadratic form. I would add, like I did earlier, to my quadratic form definition, this. Right? Because I would. I guess technically not, but we're about to make it into quadratic form, right? What are we going to do first? Okay, first of all, it asks, state the number of possible real zeros and turning points. So real zeros, what's the number of possible real zeros? 5. What's the number of possible turning points? 4. Easy. Adding and subtracting. We got it. Okay. Now, we're also now expected to find them, right? Find the real zeros by factoring. So what should we do?
Take out 3 and then extra 3.
3x cubed we're going to take out. So we end up with x squared minus 6x plus 9 with not an x to be seen. And then we factor it into x and 3 and minus. Which means the zeros are x equals 0 and 3. So we can have up on this particular quadratic, we can have up to 5, but we only had 2 because we had some repeating ones. Now, that's a little bit weird. Think about it for a minute. I know y'all aren't familiar enough to jump out at the weird yet. Don't do it. Don't cheat yet. I'm about to have you do it, but don't cheat yet. Don't cheat yet. Okay. What is the end behavior of this going to look like? It is odd.
That means it's going to be different direction.
It is positive.
It's positive.
It's going to go like that.
So it's going to go like this. Right? On the end behavior. And yet somehow it has only 2 x-intercepts.
It's one of those things where it's like a flat line.
It's a good thought. It's a good
It's
guess.
going to graze it.
It's going to graze it.
It's going to graze it.
Flat line, something. Shove in your calculator and let's see what in fact does happen.
Oh, that's your calculator.
You can try to figure that out. It's faster than yours.
I think I have a good guess.
It's different enough than TI that it took me a minute and just a little bit of looking to figure out how to work it at first, but now that I'm used to it, I actually really like it a lot, actually. I inexplicably have kind of become a Casio fanboy. I don't know how that happened. But they're like categorically better in like a lot of ways.
I love my Casio.
Ignore the random dot, that's from the stat plot thing.
That's what now?
Ignore the dot, that's from the stat plot.
Oh, okay. Looks cute.
Oh.
Oh. You probably just want to click zoom out would be the easiest.
Yeah.
I wasn't laughing at Garrett. I was laughing at your response to Garrett. I didn't think what Garrett did was particularly funny, but your response was funny. I get an undefined variable error a lot when I'm doing the HP on my computer because the X on the emulators, it has to be a capital X. So if I'm typing it on my keyboard, I accidentally hit just regular X.
Graph faster is speed calculator.
So it goes through the origin and then just boop.
Yeah, and then it just kisses the thing. So it does a little S curve at 0, so that kind of fits the odd. That's kind of like a cubic, right? Got S curve right there, and then it's like, oh, just kidding. Oh, just kidding again, right? Quite fun. Graphs get a lot more fun in this class. In Algebra 2, they're so boring. Interesting is fun. They are cool. But not 3D. We don't do any 3D.
Don't drop your calculator.
Yeah, don't break it.
Why am I seeing that?
That's in the.
My Windows hit the problem.
Well, you should see it because it's at 3.
All right, I'm just going to erase this.
Should be seeing it.
I actually
Alright.
need a Casio, Sean.
Well, you're welcome to rent that one for 15 bucks.
You think I have money?
Right? Or you can buy one for 60 bucks,
Actually, I do have money because I'm getting my.
which is awesome. That's why I went with this calculator originally, was because they make a $60 full function graphing calculator. Freaking amazing.
I just got this because it was like the.
That is like that's the most standard, like anything. Like that's this calculator in the world of education is the benchmark for graphing calculators, and it is quite a fine calculator. If you take stats in college, it does stats really easily and really well.
I read the stuff in the thing and I was like, yep, this seems good
This
for
matches.
college.
Yep. No, it works great. Now, if you do calculus, it's much more annoying to do it on there. I mean, it's annoying to do it on there too. You have to get into something like that.
Like a TI-89?
Yeah. That's why I own a TI-89.
This thing is so old.
Yeah.
Rather than my dad's, where you have to enter the number, enter the other number, and then enter what operation you want to do with it.
Well, there you go.
I think it might be an engineer thing. I don't know.
It could be. It sounds like a programming type thing. Repeated zeros, which we kind of just saw an example of, right? If x minus c to the m is the highest power of x to the x minus c. So let me pause and make sure we're following along. Higgest. Okay. Following what's happened. So if we factor a polynomial into, and we've got all these factors, and we have some factor x minus c, then once we put them all together, like we've got x minus c, oh my gosh, and then x plus 5, I don't know, whatever, right? Then the m in this case would be a 2, right? So it's the highest power, like the number of that factor is basically what we've said so far, right? That's kind of what's happening. Yeah? So that is a factor of polynomial function f, then C is a zero of multiplicity m of f. Right? So that's definitional, and we're gonna write some things that are true when we have certain multiplicities of a zero, right? So this is simply definitional. If we have a factor and it's repeated, then it's a squared term or a cubed term if there's 3 of them, or if there's 4 of the same factor, then it'd be multiplicity 4 or whatever else. This is simply definitional, right? Makes sense so far? Easy peasy? Now, the multiplicity matters. Now, we just saw one where the multiplicity caused it to just kiss it at the thing. It had a multiplicity of 2, right? Because there were 2 of them, right? So that's what we just saw. So if it has odd multiplicity, which was not what we just saw. If it has odd multiplicity, then f crosses the x-axis at x equals c and the value of f of x changes sign. At x equals c. So we saw that in the last one too, because there were 2 different things, multiplicity, right? Because remember, we factored this into x cubed something, right? Times x, whatever it was, minus 3 squared. So we had this 0 was repeated. It had a multiplicity, it had an odd multiplicity, and that's exactly what it did. It went and juked over right there, right? If it has an even multiplicity, we saw that, then f of x is tangent. No, but that's not the kind of tangent we're going to mean. I was actually about to say some of those words, to the x-axis.
That one makes infinitely more sense than the first one.
At, oh, well, there you go. X equals c. And f of x does not change signs. right? So we saw that too, where it came and it just kissed the thing. Tangent in this context is talking about the geometry tangent, right? Where like a tangent line just kisses the thing at one space. So it just kisses it at one point. So that's the tangent we're talking about here, not sine over cosine. We will talk about that later. Oh yes, that is my favorite part of this class. I can't wait to get there. I love it. So much fun. And we get to do all the cool things. We get to do proofs and awesomeness. It's awesome. So much fun. I love it. It's like a puzzle in every bite.
It is 12:33, by the way.
Is it? Well, it's a good thing we have 7 minutes because we're about done. Yeah, look at that. We are actually going to hit conics, I believe. No, not today. The circles aren't polynomials. Let's do 6a.
Is it just the examples left? Or is there?
Actually, we better do 6b. So it's just this one example, and then we're done.
I almost fit it in 2 pages.
All right. So we're going to do page 102. Guided practice. Whatever it is. 6b. All right. So we're going to look at h of x. Oh my gosh. Equals negative x cubed plus 2x squared plus 8x. Okay. So the instructions say apply the leading term test, determine the zeros, and state the multiplicity of any repeated zeros, find a few additional points, and then graph the thing. So the leading term test is where we look at the end, we're looking at the end behavior, right? So what is the end behavior of this going to look like?
It's gonna end up going down, and it's gonna
Do something, and then it's going to keep going down, right? Yeah, it's going to be something like that, yeah? And so you would write that, for the sake of time, I'm going to not do it at the moment, but so we get this problem at least mostly finished. But you would write the limit as x approaches negative infinity is positive infinity. The limit as x approaches positive infinity is negative infinity, right? That's what we would write on this particular problem for that A part, right?
3 arrows is 3 and turn points is 2.
Correct. Possible leadings, yeah, all of those words are correct. And then we're going to factor the thing. So we're going to pull out a negative x, I almost said squared, and I was going to be wrong. And then we end up with x squared minus 2x minus 8. Negative x, and then we factor this into x and 4 and 2 and negative and plus. So the zeros are 0 and 4 and negative 2, all multiplicity 1.
Wait, is there a negative 4 and 2?
No, because when we set this equal to x minus 4 equals 0, we add 4. Yeah. Okay. Then we need a few more points. So you want to pick some points in each one of these regions. So, what?
3 with a multiplicity of 1. Where did we get that from?
They all have a multiplicity of 1 because there's only one of each one, right? If it was x plus 2 and x plus 2, then it would be negative 2 would have a multiplicity of 2. So let's pick one over here. So how about negative 3? Sounds good. And then let's pick one at maybe negative 1, which would be between these two. And then you can pick something between 0 and 4. So how about 1 and then something bigger? So we pick all of those. The fastest way to do this math at this point And if you're showing all this work, this is fine, but you can shove this in there and look at the table and get these, right? Because this is just simple substitution stuff. 21 for the first one? Is that what you said?
21, negative 5, 9, and then negative 35.
Okay. Then we stick all our dots on a graph and we connect them. Using all of our brains and our drawing ability to make something beautiful. So put our zeros at 0, and then at negative 1, 2, and then at positive 1, 2, 3, 4. Over here at negative 3, it's already up to 21, so something way the heck up there. And then at negative 1, it's at negative 5, so about there. Isn't that cute? Everybody's favorite. And then up here, and then 1 and 9, and then, isn't it beautiful?
This is the last thing.
It's the last thing. And I'm going to tell you the homework. I'll put it on the Google Classroom as well, but I'm going to go ahead and tell it to you right now as well, because why not? If I can pull up the right thing, I will. Right? Precalculus is the place to be. Unit 2. And polynomial functions, page 104. Numbers 2 through 42 evens. Do I actually think you need that many? Let me look and decide if I want to take exception to past me's suggestion. Let me look. Yeah, I think that we're going to modify that because that doesn't seem necessary at all. I think let's do, honestly, you could totally do that. Yeah, I think that's reasonable with all the graphs. 24 through 32.
That's it?
The 32 or 42?
42, definitely 42.
Oh, you said 32, and I was like, what?
I don't know what I said, but 24 through 42. I think that's easily enough for you to figure out whether you understand what you're doing or not.
Is the homework just doing the problems? Or do we have more notes?
No, that's it. Yeah. Yeah. No, I like all of that plan right now. That's wise.